everyone, I am Daojie, one of the power leader for the math subject. Today we are discussing about the chapter 9, which is the random variables, and we are focusing one of the topic, which is the discrete random variables. So I will start with some simple introduction for the random variables. As we know, discrete random variables is a random variables that can be counted in the exact values. For example, in the event x, it has the value of 0, 1, 2, 3, and 4. And for example, for the events, it's such as the number of cars, number of employees, and number of fruits. Okay, now we are moving on for the examples. So a fair coin is tossed 2 times and determine the random variable x, which represents the number of tail of tennis. And so we can put the event x as the number of tail, and we know that the coin either have the result, which is the head or tail. So we can build a tree diagram. And this is the first toss, either he get a head or get a tail. And the second toss, we can get a head or tail also. For the tail also have the 2 possible results. So we can do a sample space, and the sample space either we can get a first toss is head and the second toss is head, and the second result is the first toss is head and the second toss is the tail, and the third result is the tail and the second toss is the head. And also for the fourth result is get 2 head. It's get 2 tails. So we can know that from the sample space, we can know that the number of tails that we get is either 0 or 1 or 2. Besides, we have one method to differentiate either it is the discrete random variables or the continuous random variables. So when the result come with the integers and does not have any decimal place, we will categorize as the discrete random variables, and this is the method to differentiate either this is the discrete random variable or the continuous random variables. So that's all for the introduction for the discrete random variables, and we will proceed to another power leaders.
Three, two, one, go!
Hi everyone, my name is LIOW and one of the pulse leaders of the maths in College Matriculasi Johor. So first of all, now we proceed to the probability distribution of a discrete random variable. So first of all, what is the discrete probability distribution? So the discrete probability distribution is a list of all the possible values of the random variables with their corresponding probabilities. So as we can suppose say x1, x2, x3 until xk, and this is the discrete random variables. So their probability will become probability x equals to x1 and probability x equals to x2 until probability x is equals to xk. So how we determine that it is a discrete random variable? So it will become a condition, which is all the probability of the probability x1 plus probability x2 until probability xk will equals to 1. So as we found that it can become like this, so we can consider it is discrete random variables. So if x is a discrete random variable, we can know that the probability of x equal to x1 or x equal to x2 or x equal to xk, it probability will be in between 0 and 1. So let us proceed to the examples. So for the example 1, like the previous power leader say that this is a it is a discrete random variable. So how we can show that it is a discrete random variable? So first, if we need to show, we need to know that the probability to get a head is 1 over 2, isn't it? So the probability to get a tail also 1 over 2. And this also 1 over 2, this also 1 over 2, this also 1 over 2. 1 over 2. So the probability to get HH is 1 over 4. And this is HT, which is also 1 over 4. And this is also TH, which is also 1 over 4. And this is PT, also 1 over 4. Okay, so now we need to add all the probability of the outcome, and we need to show that all the probability is equal to 1. So probability x equals to x equals to 0 plus probability x equals to 1 plus probability x equals to 2. And this x is the number of tails. So as we can see, the probability of the x0 is 1 over 4. It is head, okay? Plus, and this, there is 2 for the x1, x equals to 1, which is tail and tail head. So it is 1 over 2. And then the probability for x equals to 2 is tail, which is 1 over 4. So we can get that all the sum of the probability is equal to 1. Since all the sum of the probability is equal to 1, it is discrete random variable. So okay, so in this chapter, we also need to know that the way to construct a probability distribution table. So we can construct like this. This is the table. And the upper part is the x, and the lower part is the probability. Okay, so our x got 3 values, which is 0, 1, and 2. And then our probability, which is 1 over 4, and for the probability 1, this is 1 over 2, and probability x equals to 2 is 1 over 4. So this is the way that we construct a probability, probability table. Yeah. So for the C, we can another ways to construct for the graph of the probability distribution of x for the discrete random variables. We can do like this. This is the y-axis is the probability, and the x-axis is the x. So we can see there is 3 types, which is 0, 1, and 2. And we got 2 probability, which is 1 over 4, and then 1 over 2. So for the probability that for the x equal to 0, it is 1 over 4. So we need to cross here, and then we join out. And then for the probability x equals to 1 is equal to 1 over 2. So we need to cross at here, and then join out. And for the probability that x equals to 2, it is 1 over 4. So we also cross and then join out. So for this situation, we cannot connect all the points. We cannot connect like this, because this graph is not for the continuous random variable. If our question is the continuous random variable, we need to connect all the points with the line. So for this situation, it is discrete random variable. So we no need to connect the points with the lines. So let us proceed to the another part. So for the another part, if the question asks for the D part, okay, if the question asks need the probability that x less than 2. So how we do it? So we can see at the we can equals to probability that x, and we see at this table which is less than 2 is 0 and 1. So probability x equal to 0 plus probability x equal to 1. And then we can get that 1 over 4 plus 1 over 2. And the final answer is 3 over 4. Okay, so for one type of question, it will ask find the mode for this question. So how we find the mode? The mode is the highest probability of the x. So as we can say that x equals to 1 is the mode of this question. Okay, so that's all from my part, and now we will proceed to the another power leaders. Thank you.
Hello everyone, I'm MENG. So I'm one of the power leaders for my subject. So today I would like to discuss about for the cumulative distribution function. So if f is a discrete random variable, whereas the probabilities of summation of the probability for all of the random variable x is equals to 1. So pf equals to x until x1 until xn equals to 1. So that the fx is equals to the cumulative distribution function is equals to px equal or less than or equals to x, which means that the probability of itself and previous one will sum together, so equals to this formula. And also for the another formula for the cumulative distribution function is we have an interval between two random variable x. So when x is greater or equals to x equals to 1 or less than x equals to 2, so we use this formula fx2, which is the cumulative distribution function for the x2 minus the small random variable x, x1. And another thing we have to learn in a cumulative distribution function is about median. So median is the value of m when we use these two formulas. It depends on the question. So if the probability, we have to use px less or equals to m equals to 0.5, or we use the cumulative distribution function terms, which is fm equals to 0.5. So we now proceed with the question to enhance your understanding. So the example question is the cumulative distribution function for fx or the discrete random variable x is shown below. So you can see that the fx for the number 7 is 1, so it's shown is a discrete random variable x. So the question wants to find the probability of using the cumulative distribution function fx. So it has to use the this table given to solve this following probability. So the first one is the px equals to 4. So according to the formula, px equals to px less or equals to a minus px less or equals to a minus 1. So it's cumulative fa minus cumulative a minus 1. So we use this formula in our question A. So question A, px equals to 4 equals to the cumulative function for the random variable f 4 minus f4 minus 1. So is the f4 minus cumulative function for random variable x 3. So you can find from the table. So f4 is the 0.7 minus the f3, which is the 0.3. So you get the answer is 0.4. Okay. So we proceed to the B. So B is ask you the probability x less or equals to 4. So we use the definition for the cumulative distribution function, whereas the px less than m equals to fm. So we related to the B. So p x less or equals to 4 equals to cumulative function for 4. So definitely we can find from table. So it's 0.7. Just directly can read from the table. And C, we ask you to find x less than 5. Because it's the less than 5 not equal, so we have to relate it to the formula that can be use this definition for the cumulative distribution function. So if the px less or equals to 4, so we can relate it to the f, so equals to f4. So f4 is definitely 0.7. So we now proceed with another 4 questions. So the D is px greater than 3. So we use this formula. So for D, px greater than 3. So equals to 1 minus px lesser or equal to 3. So we can write this with the f function. So 1 minus big F 3. So you can just use in the table. So 1 minus 0.3 equal to 0.7. Okay, so we now proceed to D. D, he asks you P probability X greater or equal to 5. So we use this formula. 1 minus P X less or equals to 5 minus 1 equals to 4. And we relate that again with the big F function. So F4. So it's 1 minus 0.7 equals to 0.3. Okay? And the next one is F. F, he asks you for the probability has two intervals. So X greater or equal to 2 and less or equal to 5. So we use the third formula. Cumulative function of B. So B is 5 and minus F. 2 minus 1 is 1. So F5 is 0.85 and F1 is 0.05. So we get the probability is 0.80. And the next one, we ask you the probability the X is greater than 2 but less than 6. And we use the last formula, whereas the B is our 6, so 6 minus 1 is 5, minus F8, F2. So F5 is 0.85, can already read from the table, and F2 is 0.15. So we get the answer is 0.7. Okay, so we proceed with the last 3 questions. So the first one is he wants us to find for the median. Due to the question is given for the cumulative distribution function, so we use the one of the formula which is big F m equal to 0.5. So we have to determine what is the value of random variable x, which is have the value of 0.5. So you can look at the table. The 0.5 is lies between the 0.3 and 0.7. So it means that the MENG either is 3 or 4. But due to the maximum cumulative function for 3 is 0.3, so the 0.5 will be placed in the x equals to 4. So the answer for H is m equals to 4. And next, he wants to outline probability distribution function, which is small f x. So first of all, we have to find for the probability distribution function table, and then we just create the probability distribution function. So we draw a table. Okay, so this is x. This is P big X equals to small x. So Px1, because there's nothing for the previous one is a 0, so we just copy back 0.05. And then the number 2, we have to use the formula, whereas the Px equals to x equals to P Fx minus Fx minus 1. So for this case, Px equals to 2, set to F2 minus the F1. So it's 0.15 minus 0.05 is 0.1. And the third one, use the same method, so it's 0.3 minus 0.15, so you get 0.15. And number 4, 0.7 minus 0.3, so we get 0.4. And random variable 5, 0.85 minus 0.7, so we get 0.15. And we proceed with the random variable number 6. So F6 minus S5, so F6 is 0.95 minus F5 is 0.85, so we get 0.1. And the last one is 7. So 7, we just take F7 minus F6, so we get 0.05. And now we have to create a probability distribution function. So P x equals to x, and then equals to big bracket. We can categorize the probability with the same value, which is 0.5. We start with 0.5. At 0.05, there are two values that have the same probability, which is x equals to 1 and also x equals to 7. And the next one is 0.1. So 0.1, x has two values, which is the similar probability, which is x equals to 2 and x equals to 6. And the next one is 0.15. So 0.15, we have x equals to 3 and also x equals to 5. And the last one is 0.4. 0.4 has one value, x equals to 4. And the last one, you want to find the modes. So modes in this chapter, it means that the random variable, which is the value of small x, which has the higher probability. So I can refer to the cumulative distribution function, not for the probability distribution function. We can also refer to the probability distribution function, which has the highest p-value. So definitely the answer x equals to 4 because it has a highest value of p, which is 0.4.
Hello everyone, I'm GUAN. Today I'm going to explain the expectation and variance of discrete random variable. The mean is equal to the expectation of S, which is the summations of the random variable S times its respective probability. And the E times the function GS is equal to the summation of the function with times the expectation of the S. And these are the some example of the formula we can use. Next, this is the formula of the variance, which is the expectation of S squared minus the bracket square of the expectation S. And then these are the some example formula that for the variance. This is one of the example of the expectation and variance of discrete random variable. S is a discrete random variable with probability distribution given by P, S equals to K, S equals to 2, 4, and 6. P, S equals to 2K, S equals to 1, 3, and 5. A, find the value of K. So we need to find the value of K. We can get from the formula, which is the sum of the probability of discrete random variables is equals to 1. It means that the discrete random variable from 1 to 6 is equal to the 1. And then the PS equal to 1 is 2k times 1 plus the PS equal to 2k. Then the PS equal to 2k times 3. PS equal to 4k. And PS equal to 5, 2k times 5. And PS equal to 6 equals to k. And then so you can get 21k equal to 1 and k equal to
1/21.
Question B, expectation of S. To find the expectation of F, we need to find the summation of random variables times the probability, which is the 1 times 2/21 times 2 plus 2, 1/21 plus 3, 6/21 plus 4, 1/21 plus 5, 10/21, and last 6 plus 6, 1/21. And we can get the answers is 82/21. The second example, the probability distribution function of a discrete random variable as given as follows. This is the probability distribution function. Question A, variance. To find the variance, we need to use the formula E expectation of S squared minus expectation bracket squared. So we need to find the expectation of S first. And 3, 1/4, the expectation of S equals to the 41 divided by 60. The expectation of S squared, 1 square times 1/16 plus 2 square times 1/2 plus 3 square 1/4 plus 4 square 3 times 3/16, and we get the expectation of S squared is 117/16. So we find the variance S. The formula of variance S is equal to the expectation of S squared minus expectation of S bracket squared. And then expectation of S squared minus expectation of S bracket squared. The answer of the variance is 191/256. Question B, find the variance S minus 1. To find the variance S minus 1, we use the formula formula D. So we can get the variance S minus 2 is variance S, and then the variance S is 1 times 1 divided by 256.